Limits of functions of two variables.
Let's start by reviewing what we know about limits of functions of one variable. If we want to consider the limit of f of x as x approaches c, it's equal to L only if the limit from both the left and the right of c are equal to L. It's important that we consider the limit from both sides to determine if the limit exists. Now, if we consider the limit of a function of two variables as xy approaches ab, the limit of fxy is equal to L if the limit from all paths approaching AB exist and are equal to L. The problem here is that if this is the point AB on the surface, there's an infinite number of paths that we could consider to determine if that limit exists. So, we have to figure out how we're going to determine the limit if there's potentially an infinite number of paths to consider. Remember, with functions of one variable, if the function was continuous around the value of c, we could determine the limit by performing direct substitution. So, we take this value of c and just plug it into the function if the function is continuous around that value. Well, the same is true for functions of two variables. If the function is continuous, then the limit as xy approaches ab of f of xy is equal to f of ab if we know the surface is nice, smooth, and continuous. It is important to remember that if a function is not continuous at ab, this does not mean the limit does not exist. We will need to consider approaching ab from different paths. Let's take this function as an example. Notice that if we try to do direct substitution, we're going to have 0 over 0, which is an indeterminate form. Since we can't perform direct substitution, we're going to approach this from different paths and see what we can discover. Let's consider the path where y is equal to x. If y is equal to x, we can rewrite this limit as a limit as x approaches 0. So this would become x times x, or x squared, all over x squared plus x squared. Now, by simplifying this, we get x squared over 2x squared, which is equal to positive 1/2. Now let's consider the path y equals negative x. So again, we rewrite the limit. Now since y equals negative x, we get negative x squared over x squared plus negative x squared, which is equal to x squared. Simplifying this, we have negative x squared over 2x squared, which is equal to negative 1/2. So what we've done here is approach 0 along the line y equals x and the line y equals negative x. And since the limits along these two lines are not equal, we can conclude that the limit does not exist. For our last example, we get the limit of the same function as xy approaches 4,2. Now, if we try to plot the point, it is somewhere around here. So, as we can see, it is continuous at around this point, and thus, we can perform direct substitution to determine the limit as xy approaches 4,2. Just because there wasn't a limit approaching 0, 0, doesn't mean there won't be a limit approaching 4,2. So now, we have 4 times 2 all over 4 squared plus 2 squared, which is equal to 8, all over 16 plus 4, or 20. This limit is going to be equal to 2/5.